What's up everyone, welcome back. Patrick here, and in this video what we're going to talk about is popular types of set operations, and more specifically the union and intersection of sets. And just as a heads up for simplicity, in this video we're going to talk about the union and intersection of two sets, but really these operations can be done on any number of sets, more than two sets, and we'll be doing examples where we'll be finding the union and intersections of more than two sets, but in this video we're just going to be working with two. So to start off, let's say that we have two sets. As an example, let's say A and B. So the union, and actually the union and intersection of sets, these are sets themselves. So I'm going to call this the union set of sets A and B. The notation for this, the way you're going to see unions represented is A, and then you'll have this U here, B, like that. And then if there's more than two sets, you'll continue having like a U, C, U, D, etc., etc. Right? So this represents the union of sets A and B, the union set of sets A and B. And basically what this set gives you is the set of elements in A or B. All right, while the intersection set of sets A and B, the notation for that is you're going to have like an upside down U in between the sets. So you'll have A intersection B, and this set is going to be the set of elements in A and B. So notice the difference in the wording. Actually, the only difference in the wording is the word or and the word and. So the union set is the set of elements in A or B. And this one is the set of elements in A and B. So this one, the intersection, is more restrictive than the one up top. So the number of elements, if you're dealing with the same sets, the number of elements in this set is always going to be less than or equal to the number of elements in this set. It's more restrictive, so there's going to be usually less elements in this one because it has to be in both of them, while this one it's in A or B. So you'll have elements in this set that could be in A but they won't be in B. You'll have elements that are in A and B. It'll include these elements here. And then you could also have elements that are in B, but not in A. So let's do a quick example here to show how it works. Let's say that, let's do a simple example. Let's say that we have set A. If we put it in roster notation, let's say it's 1, 2, 3, and 4. And let's say set B is, let's do -1, 0, 1, and 2, like that. So what is the union set going to be of both of these? And then what's the intersection set going to be of both of these? Let's actually start with the intersection set. It's more restrictive. There's going to be less elements. So remember the intersection set, it has to have the elements in both A and B. So if you look at these, which elements are common? Well, notice the 1 and 2, and then the 1 and 2. So that's going to be the intersection of both of these. So it's going to be 1 and 2 over here. That's going to be the intersection set. While the union set is going to be in this set or this set. So it's basically going to be all these elements. So we'll start with -1, 0. And then notice that 1 and 2 are common in both. But remember, if you remember the original definition of a set, there are no elements that are repeating. It's all distinct elements. So even though they're appearing in both of these, we would only write them once over here. And then we got the 3 and the 4. You can also show this visually. So a popular way to show this is notice that there's going to be an intersection here. So let's say that this circle here is set A, and then this circle here is set B. So notice that the intersection of both of these is this space right here. It's in both A and in B. And that's going to be these two elements, 1 and 2. And then notice that this area here is the elements that are in A, but they're not in B. So what elements are those? 3 and 4. And then over here, this area, it's the elements in set B, but not in set A. And that's going to be 0 or -1 and 0, like that. Right, so notice this circle has all the elements of B, and then this circle has all the elements of A. But more specifically, this area is the elements that are both in A and B, the intersection of both of them. So that's another popular way to show how unions and intersections work. And so what we're going to go through in the next couple of videos is different examples where we have to find the union and intersection of sets. And the level of difficulty is going to range for these examples. So I'm going to try to throw as many different examples, as many different scenarios as possible at you.